Good afternoon, everyone. Today I'm going to look at how to animate a Ferris wheel prop using physics. Okay, the prop I'm using comes out of DAZ. You can find Ferris wheels in Sketchfab or in many places. The key being that you want to be able to separate the Ferris wheel from the wheel, a base, and the seat itself. And then what we'll be doing is using the physics to animate the seat so that it swings back and forth as the wheel circles around. Okay, so like I said, I've separated my DAZ prop into three pieces. I have the Ferris wheel frame. Let's put that in. Dun, dun. Ferris wheel frame. And there we go. Okay, that's the frame. I'm going to go up and what am I on? There we go. Sorry. I'm going to zero it out. Okay. That is the frame. Looks good. Okay. Next, I'm going to load in the Ferris wheel itself, the wheel. Ferris wheel. Give it half a second. There it is. Looking good. Feeling good. Okay. And it loads nicely into the correct place at zeros because that's where I saved it inside of DAZ. That's where it was positioned in DAZ. So saving it from there, the position that it comes into Iclone would be at 0, 0 for the X and Y values, and it lines properly. So okay, now we have our base, now we have our Ferris wheel, and let's load one Ferris wheel seat. Here it is. As I think I haven't said this yet, but DAZ had some morphs that would animate the wheel. The problem is some of the values in that morph were very large so that the wheel would rotate multiple times, and that didn't come in. And the other problem being morphs are very difficult to get into Iclone. I was using 3D Exchange. I was able to get the morph in, but it only animated a very small portion. The second part of the problem is that using the morph to animate is very static. The wheel, it doesn't feel alive, whereas when we're using the physics, you're going to see that it's going to swing a little bit, and it's going to give you an added effect. It's going to feel a little more real. Okay, anyway. So here's the seat. Again, I'm going to zero out the values, and it should be aligned properly. There we go. Yeah, it's right in its correct position. So there we go. And once we get all of our physics set, all I'm going to have to do is copy that seat and align it properly in the right positions across the wheel, and we should be good to go. But for now, there is no physics. Okay, so I'm going to set up the physics contraption. So I'm going to hide what we have right now, and I'm going to load in three very simple 3D blocks. First is going to be a cylinder. That cylinder, position it like this. Let's see, 90. We'll raise it up a little bit. That's fine. Okay, there's our cylinder. Actually, let's make it a little bigger so we can see it. There we go. Make sure that our pivot point is in the center of the cylinder. Okay, and then I'm going to load a very simple box. There we go. Looks about right. Make sure everything is 0. That moved a little bit. There, perfect. Okay. Let's see. Okay, so groovy. Here we have what will, in effect, run the Ferris wheel. It is our Ferris wheel cylinder, and this will be our seat. The props that I have shown you that come in from DAZ will actually just be linked to what we're going to have here. Okay, so what kind of physics are we going to use? The cylinder in the middle, we're going to turn on the physics and we're going to use kinematic on this cylinder. Okay. Now when I hit start, if you're using dynamic, it's going to fall out of the sky because there's gravity, and then because there's no infinite plane, it would fall below the plane and just drop forever. But kinematic will hold it there. And then for what's going to be our seat prop, we're going to activate the physics, and we're going to leave it as dynamic. And now that one will drop off the face of the Earth because it has gravity, right? So how do we fix that? How do we make this, which will be the seat, associate it to what is in effect the wheel? What we're going to use is a physics constraint. So the physics is on, it's set to dynamic. I scroll down to the bottom and we have add constraint. And there's many different types of constraints. I've gone into this in other tutorials. The one we're going to use here is just a simple hinge constraint. We grab it, we pull it down onto the prop, and you can see it's trying to align itself onto the visible faces. It's saying, well, how do you want to associate this hinge? And I want it on the side, right there, because my seat prop is going to swing in the manner that it's going to show me this hinge. It's going to swing, see the arrows there? Swing like that. Now, since I've zoomed in, let's get that hinge about in the middle and pull it up to the top. Okay? And then the second part, I can close this box here. The second part of this hinge is the target. Currently, the target is the world. But what we want that hinge to be associated with the wheel itself. So I simply pick target, click on the cylinder, and let's see if it falls off the face of the Earth. It does not. It's swinging a little bit, and that's fine. That's what it's supposed to do. The swinging probably tells us that the hinge is not aligned in the middle. So let's back it up on the timeline. Let's go in, make sure we have our hinge selected. We do. And let's move it over just a tab to the left. Let's see how that works. That's definitely a little better. See how it's not swinging as much? And because gravity is in effect, this is why I moved the hinge up to the top. And we're going to do something else later that will also help our animation, which is to move the center of gravity of this box much lower. Currently it's in the center, which is here. We're going to move it down. But for now, this is fine, and I'll show you why. Here we are. We have what will be our seat. We have what will be our Ferris wheel. Now I'm going to animate the cylinder. Let me just zero out that cylinder real quick. I had some issues on a previous attempt at this, so I'm going to reset the transform. Think that's good. Hope so. And we're going to pull the timeline ahead 10 seconds. And I'm going to rotate the cylinder. We will rotate it, let's go 360 degrees, negative 360 degrees. And let's see if this works. Look at that. Already, we see that we're getting some physics results, and it's starting to look kind of cool, right? Now, obviously something weird happened. Let's watch it again. This is rotating, this is constrained, it goes up, but why is it staying upside down? Well, let's go back and look at the hinge itself. When we go down to the hinge and we slide down, it can either be locked, here it has a limit, and here it's free. Now, the limit here is negative 90 and 90, so when it starts going up, it stops at 90 degrees. That's why it has a limit, right? So we can see right there, 90 degrees. All right, so what we're going to do is we're going to change this from the limit to free. And let's see how that works. Ah, that didn't work either. Okay, that's fine. You really got to play with this a little bit. There's a lot of settings in here that you can use. When we go into our box, which has the dynamic gravity, or I'm sorry, dynamic physics set, you have all these properties that you can play with. Elasticity, mass. I like to put my mass up high and everything else stays pretty down low. And like I said, the secret for me that I like, or the way that I work with this, is if you scroll towards the bottom, we have the center of mass, right? Make sure you're on the box, not the hinge. Edit the offset, and if we look at where the center of mass is right now, it's basically in the center of the box. We want it to be lower. Now the center of mass is much lower, and that should help to hold things steady. Let's see if it works. And you know, one of the things about this rotation, it's going really fast. That's much faster than a Ferris wheel would go. We could, let's see, if we take, cylinder, there we are. If we move this out about twice there, so now it's at 20 seconds, so it should be 20 seconds for that rotation. Let's see how that works. See, it's much better. Now our seat is staying basically upright. Yeah, that's much better. That looks like that could actually work as a seat, as a Ferris wheel seat, without dumping the person out of the seat. Okay. Zoom in. Let's play a little bit more. You know, honestly, that's going to be good enough for me for right now. Rewind it. Let's watch it one more time. Coming up. Yeah, that's not bad. You'd like it a little looser right there, but he stays upright for the most part. Yeah, that's not bad. Okay, I'm gonna go with that for now. But like I said, if you want to play with these settings, you go into the box itself, and you can find a lot of the properties here: mass, friction, dampening, and elasticity. And then there's a few other things you can do, such as playing with the center of mass. Don't worry about initial force, that's not something you want to deal with. But the hinge itself also has a few more settings, especially if you change it back to your limit. You can do a hard limit, a soft limit. Again, I find it best to use free, and just to deal with the center of mass and the elasticity, those things, to get the what you're looking for. Okay. So this is the essential rig, the physics rig, if you will. I'm going to turn these things back on. We won't worry about the frame for now, but the wheel, okay. So we're off center from the wheel, and that's fine. We click on our cylinder. We want it to be in the center of the wheel. Easiest way to do this, let's see, yeah, we're in the center. Simply align. Use the align tool, which is right here, and then we're going to click on the wheel. We're going to go X, Y, and Z. Now the wheel itself needs to scroll down to the bottom. Oops, sorry, not in the textures. Scroll down in the attributes to the pivot point and set it to the center. Okay. Now the wheel pivot point is at the center. I go back to my cylinder. I align. I select align. Wheel. X, Y, Z. Boom. It's in the center. Much better. Now we're looking good. We can make it bigger if you want. Doesn't really matter. Okay. Groovy. Next. Let's get that seat. Let's show the seat. Okay, we're going to zoom in on that seat. And we're going to try and put this hinge constraint at where the hinge, or where the pivot point for the seat is, okay? So I've got the box. I'm going to pull it up. Be nicer if I extended it. Whatever, it's fine. That looks about right. Meaning that the arrow here aligns about right there. Okay, groovy. Now, nothing's going to happen if I hit play. My DAS props aren't doing anything because we have not linked them. Okay? Very simple now. I just go into my Ferris wheel and I go in here and I say, where is, you can attach. Attach is fine. Attach the Ferris wheel to the cylinder, right? And then I'm going to attach the seat to this box, which we've added physics constraints to. Now what happens? Look at that. And look at how the seat is swinging a little bit. Pretty cool, huh? All right. Not bad. See how it swings back? It looks a little bit real. Not bad. And now, I go back. All you got to do now, we're just going to turn cylinder into a dummy. And we go into our box, and I turn that into a dummy. And I turn on my Ferris wheel frame. In fact, before I do that, we'll just duplicate this a few times. I go into box. I'm going to grab it, and I'm going to control while I pull it up. And we're going to pull it all the way to the top, align it properly to where it should be. You can see it's a little bit low right there. This needs to be in the hole. A little too high. There. Perfect. Now, let's see. There's something yeah, that constraint is weird. The hinge itself also needs to be hidden. There. Oh, you know what? Because, no, I made it a dummy. I wonder if you can make a hinge a dummy. No. Alright, so in this case I'm just going to hide it. That's fine. And now I have two seats. And basically the method from here is to just move it around. Copy them out, put them in the correct position. Right. Aligning this piece here into the groove. And that's it. You just do that for each one. I'm going to do maybe two more, and then what I'm going to do is show you the end result. There we go. Cool. And I'm going to add one more. Let's see. I'll pop him up a good bit. Right there. Cool. Alright, let's see what that looks like. We're going to turn on the frame. And yes, I've only added 4, but like I said, there you go. And you can see how each one of them swinging a little bit as it turns. So I'm going to now show you the end result. Hold on one second. Alright, so this was the end results of using physics on those props. I've installed all of the chairs. I've also played around with the textures a little bit. I've put on some lighting. I've added some of the the global illumination using for each one of these lights here and the textures. I'll just show you real quick. Cylinder, Ferris wheel. Okay. So inside here in the textures, yeah, the bulbs. I've gone into the bulbs themselves, and I've turned up the self-illumination, and I've turned on the GI settings, right? So you can see how the middle of it, especially where the lights are, is more lit up. And then I added a character as well into one of my seats, and I added a camera here to take a look at him as he rides. So you can see him riding the there we go, riding the Ferris. Whoop. Yeah, you can set it up. He's freaking out a little bit, but yeah, you can have some fun with it, and you notice that the seat is swinging a little bit as he rides. There we go. Sorry, the camera is attached to the seat, so that's why it's getting those Dutch tilt angles. Pretty cool. So there you go. This was using physics constraints to animate a Ferris wheel. I hope that's helpful. Not too hard to do, honestly. Just basically 3 props. Kinematic physics on the cylinder, dynamic on the seat, and then the hinge constraint, which is targeted to the cylinder. And then you just basically link all your actual props to that little rig, and you are good to go. Hope that was helpful. Hope to see some results from some other people. Hope people are finding it useful and able to set up their own Ferris wheel. Okay, that's it.